It's been more than 100 years since Sir Albert Einstein gave his general theory of relativity. But what's its actual meaning? Let's understand. Firstly, we need to know that what is the difference between special and general relativity. Well, in special relativity, all the measurements are done in reference frame which are moving with constant velocity, while general relativity incorporates accelerating reference frames. Now a reference frame is a frame which you consider to be at rest and do all your calculation with respect to that frame. General relativity is also a new theory of gravitation. Now in general relativity, Einstein said that the effect of gravitation and acceleration cannot be distinguished from one another. But how? Let's do a thought experiment. Suppose you and I are on a roof of a very tall building and we have a weighing machine with us. We measure our weight and it comes out to be, let's say 60 kg. Now imagine I pushed you off the building. Sounds pretty nice. Now you and weighing machine are falling freely under the influence of gravity. If you measure your weight now, what do you think it might come? Well, it comes out to be 0 as you and weighing machine are falling at the same rate, and due to which you feel yourself weightless. Now you can also call this acceleration as acceleration due to gravity. Now in general relativity, there is a term known as space-time continuum. But what is it? Let's discuss. Now we can locate our position in space by using 3 coordinate axes, x, y and z axis, and represent any point by mentioning its x, y and z coordinates. But what about an event? To describe an event, which is something that happens at a particular point in space at a particular time, you can use 4 coordinates, x, y, z and time axis. So we can say that time is not separated from space and we can use it as a single idea. Now whenever a quantity of matter exists, it's bend the geometry of space-time. This results in a curved shape of space-time that can be understood as gravity. Now here, lines does not represent the curvature of space, but instead they represent the coordinate system imposed on the flat space-time when there is no mass. Now consider 2 masses which start off their journey parallel to each other in the straightest possible path. Now, if they continue their journey like this, they'll never meet. No, actually they do meet and collide with each other. Newton says that this is because of gravity which attracted them towards each other. But Einstein said that this happened due to the distortion in space-time. The objects are still traveling in the straightest possible line, but due to distortion it is curved, which leads to the collision between the masses. Now seeing all this, Einstein came up with the conclusion that gravity was not a force at all. What for Newton it is gravity, for Einstein it is a curvature in 4D space-time. More mass, more curvature, less mass, less curvature. Now, we cannot describe space only with the help of Newtonian gravitation because one of the drawbacks is that it cannot explain the orbit of Mercury, which is quite different from other planets' orbit. Also, what Newton gave us is a formula which tells us about the strength of gravity, but it doesn't tell how gravity exerts its pull. I hope you learned something today.